All right, let's get started. Yeah, so a few reminders. You have one homework due today. That's 4.1, basically calculating some integrals. And then the next homework will be due on Monday. And I also want to remind you that the second exam will be on next Friday, April 10th. You have 3 hours to complete the exam, and it will be available all day on D2L. If you haven't done that already, make sure to check the review checklist that I posted on Piazza. And then I'll finish up 4.3 today, and then we'll start doing exam review next week. Any questions? No questions? Okay. All right, so last time, what did we do? So we talked about the fundamental theorem of calculus. And then we mentioned that it's a theorem. It's a theorem that relates taking the derivative and taking integration. It also tells you how to take the integral using antiderivative. So that's something we do we see a lot today. So here's the part 1 of the statement of the theorem. So I don't want to write the assumption, but the assumption is the function has to be continuous, has to be nice. And the statement is, if I want to take the derivative of the integral that looks like this, and this is really just f of x. So taking the derivative of an integral that gives you the function, that gives you the original function. Questions? Okay. One quick remark. So the formula only works when two things. Lower limit is a constant, and the upper limit is x. So you can only use the formula. I mean, you can only use the formula right away when the lower limit is a constant and when the upper limit is just the variable x. We'll see examples when, so I'll do more examples when the lower limit is not a constant and also when the upper limit is not just x. So first I should do, maybe I should mention again the example we did last time. So last time the question was, I want to compute the integral, the derivative of the integral of this. So this is a case where the upper limit is not just x. And then we mentioned that you have to use the chain rule. So this turns out to be, the formula is almost the same for the first part. So you want to put the secant here. And you need to replace the t by x to the 4. And then by chain rule, I need to multiply by the derivative of x to the 4. And so that gives me 4x cubed. Is it okay? Questions? Okay. Second example. Let's say I want to compute the derivative of the integral from x to 5 of tangent of t. What do we do? So the lower limit is not a constant, the upper limit is not x. What do we do? Any ideas?
You leave the negative integral.
Mm-hmm. So you can flip the lower and upper limits with a negative sign, like this. Is it okay? So when I flip the lower and upper limits, I get a negative sign. And then because I'm taking the derivative of negative something, the negative doesn't do anything, right? So you can put that out. Side the put that out of the derivative. So it's the same as this. And now you can use the fundamental theorem of calculus to this guy. The lower limit is 5, the upper limit is just x. So this is by the fundamental theorem of calculus, tangent of, you need to replace the t by x. So tangent of x, negative tangent of x. Questions? No? Okay. Next one. Okay. Should probably just say the last step is by the fundamental theorem of calculus. Let me know when you are done, Daniel. Okay. All right, next example. I want to compute the derivative of the integral of something. The lower limit is 2x, the upper limit is 6x. So, what do I do? Any ideas?
What's the top half?
6x. Do you mean the function or do you mean the upper limit?
The upper limit.
6x.
Can you take out 2x?
No. No. Okay, so if you remember what I said last time, so I said that one of the properties of integral was if you take the integral from a to c, that's the same as doing a to b and then b to c, right? You can do the same thing here. So computing the integral from 2x to 6x, that's the same as doing 2x to a constant, let's call it a. And then everything else the same. And then you do from a to 6x.
And then for the first one, would you swap it and make it a negative?
Yep, exactly. So up until this point, any questions? Let me say this again. So computing the integral from 2x to 6x, that'll be the same as doing from 2x to some constant a, and then you do again from a to 6x. If you want, you can pick a number for a. So as long as it's a point where the function is continuous, then you're good. For example, you could put 0 if you want. It doesn't matter what constant is in this case, as long as the function is continuous at that point. Am I making sense? I'm saying that you can put 1,000, 100, 99, or something, one half. As long as the function is continuous at that point, it's okay to do that. Well, I just mentioned that. So I say that it's true that so this is correct for any constant a as long as the function is continuous at a. So for example, the function is continuous at 0, so I can put it 0. The function is also continuous at 1/2, so I can put it 1/2. The function is also continuous at 99, so I can put in 99. Okay. Now for the first term, okay, so for the second term, you can do the fundamental of calculus right away. But for the first term, this is almost the same as this guy, the second example. You need to swap the lower and upper limits and get a negative sign like this. And for the second term, I'm gonna just apply the fundamental theorem of calculus right away. So we replace the u by 6x. And then because the upper limit is not just 6x, I need to multiply by the derivative of 6x. What's your question, Daniel? What is which one? I'm guessing you're asking this. This is 2x.
Would the end of that one be du instead of dx?
Yep. Any other questions? Okay. Does everyone get the second, how I got the second term?
Is it chain rule?
Yeah, it's just a chain rule plus the fundamental theorem of calculus. So let me say this again. You just need to plug the upper limit into the function. So you get 5 over 6x squared plus 1. And if it's not just 6x, sorry, if it's not just x, you need to multiply by the derivative of that. So multiply by the derivative of 6x. And for the first term, do the same thing. So you pull out the negative, and then when you apply the fundamental theorem of calculus, you get 5 over 2x squared plus 1 times the derivative of 2x. So that's it for the first term, and plus the second term. And then I need to simplify this too. So the derivative of 2x is just 2. The derivative of 6x is just 6. 2x. And that's it. Questions? Yep. Okay. By the way, I forgot to mention, did everyone get an email from Andy yesterday? So he sent out an email about the second exam, um, among other stuff. Make sure to read that email carefully. So yeah, if you didn't receive that email, let me know. Questions about this example? No? Okay. Let's move on to the okay, I'll forward the email again today. Okay, so fundamental theorem of calculus part 2. So this is a part where it tells you how to compute the integral. I mean, without using the limit formula. So let's say that you always want to assume that your function is continuous. So we need that. So you have a continuous function on a closed interval from a to b, and let's assume that f is a. Is any antiderivative? Then to compute the integral, it's the same as plugging in b and a into your antiderivative and subtract like this. So you put b inside your antiderivative, subtract, you put a into your antiderivative. This is the formula. And I will use a notation like this. So once you find the antiderivative, I will write something like this. I will write f of x, a straight line, a and b. So that means I need to put b inside the antiderivative and a inside the antiderivative and subtract. Is it okay? I'm saying this is my notation. Questions? Okay. So let's use the theorem to compute some example. So you have the integral of x cubed from -2 to 1. Before this section, the way we computed this type of integrals is to use rectangle and then take the number of rectangles to infinity and stuff. It was much more complicated. But in this section, we want to use the antiderivative. So to compute the integral of x cubed, I need to first find one antiderivative. So what is the antiderivative of x cubed? By the way, before that, technically, I need to check whether the function is continuous or not. So is the function x cubed continuous from -2 to 1? Yep, x cubed is a very good function. It's continuous everywhere, including -2 to 1. So second question is, what is the antiderivative of x cubed? So what is the function so that when you take the derivative, you get x cubed? Does the exponent get higher or lower? Okay. And what is the antiderivative of x cubed? Yep. So it should be x to the 3 plus 1 divided by 3 plus 1. That's a formula that we mentioned last week. And technically, it's still, you need to put plus c, but in this case, you don't need to do that because you want to compute. Sorry, at the end, you want to plug -2 and 1. Is it okay? So let's do it. So when you plug in 1, you get 1 over 4. When you plug in -2, you get -2 to the 4 divided by 4. And this is -15 over 4. Questions? Okay. I have one question for you guys. Does everyone see that I don't need to put plus c here? Yeah. And why is it? So I'm saying that this is the general antiderivative of x cubed, right? Because when you take the derivative of c, you get 0. So the c doesn't matter. But if I ask you what is the antiderivative, you need to put c. And then my question is, does everyone see that it doesn't matter whether I put c or not? No, the constants are not given here. No. So what does this notation mean? It means that I need to plug in 1, and then I need to plug in -2, and then subtract. When you put in 1, you get positive c. When you put in -2 and then subtract, you get negative c. So c minus c equals 0. That means the constant doesn't matter here. Does it make sense? Yep. And so if I ask you to compute an integral like this, you don't need to put in plus c. You just need to give me one antiderivative, put in the 1 and -2, and then you are done. Make sense? Okay. Second example, I want to find an area under the parabola y equals x squared from x equals 0 to x equals 1. So what do I do? So what is the area of the function from 0 to 1? No, no. It's a parabola. I tell you that it's a parabola. We don't have a formula. We don't have the geometric formula for the area of parabola. Area of semicircle minus area of square. Yeah. So what are we doing in this section? We're doing integral, right? And if I ask you what is the area of a function from a point to another point, by definition, this is just the integral of x squared from 0 to 1. Does it make sense? That was the original definition. So area under the graph is the same as the integral of a function from a given point, from the initial point to the end point. Is that okay? And then again, in previous section, you need to do, all the limit stuff and then use the rectangles thing and then find out what is your delta x, what is the heights and stuff. But in this section, fortunately, we have the fundamental theorem of calculus. It tells you that I only need to compute the antiderivative of x squared. Can someone give me one antiderivative of x squared? Yeah. Well, not exactly. So the antiderivative of x squared should be x to the 2 plus 1 divided by 2 plus 1. And then evaluate that at 0 and 1. Okay. And now you plug 0 and 1 into the function. So you should get 1 over 3 minus 0 over 3. So the final answer should be 1/3. Questions? Okay. One thing you should be careful is if the function inside the since there's no negative, is there still plus c? What do you mean? What do you mean by since there's no negative? Yeah, so you get a c when you plug in 1. You get another c from plugging in 0. They cancel out each other, so there's no c at the end. Okay. What do I want to say? Yeah, so remember part of the assumption in the fundamental theorem of calculus is the function has to be continuous, right? You need to be careful here. So if the function is not continuous, then you cannot use the fundamental theorem of calculus. Cannot use. I'll give you one example. This is why we need to be careful. So let's consider the function 1 over x squared from -1 to 3. So if I use the fundamental theorem of calculus naively, what should this be? So if I'm very naive and use the fundamental theorem of calculus, what should it be? What would I do? Okay, you find the antiderivative. So you would find the antiderivative of x 1 over x squared. So 1 over x squared is the same as x to the -2nd. Let's just write that. And then what you get, the antiderivative of x to the -2nd should be x to the -1 divided by -1. And then when you need to plug in -1 and 3. So you do that. So you plug in 3 and then you plug in -1. The final answer you get should be -4 over 3. But then this is not correct. So let's see what is 1 over x squared. What does it look like in the graph? 1 over x squared should look like this, right? Let me do the next page. So 1 over x squared looks like this. And let's say -1 is here. 3 is here. So everything is positive. So what do you think the area should be? Is it positive or negative? Yep. So because everything is positive, so the graph is above x, your integral should be positive. Always positive. That means this guy should be positive. But then my calculation told me that this is negative. So that means this is wrong. And I cannot use fundamental of calculus here. Questions? Okay. All right, let's do a few more examples. Ew. So let's say I want to compute the integral of x plus 1 times 2x plus 1 from 1 to 3. What do I do? Can I split the integral?
Zig's reaction is to you. Because that's absolutely repulsive. What?
Okay. No. Okay, so you're taking a product of two functions, x plus 1 and 2x plus 5. To compute the integral, you cannot split the integral into two parts. Right? In this case, what do we do? Yep, so I need to multiply everything out. So you fold it to get 2x squared plus 2x plus 5x plus 5. And And let's simplify them. So I have 2x squared plus 7x plus 5. Questions? No. Can I split them up? Yeah, okay. Yep. So I can do this. So I'm doing this because I want to make sure you know, for product of two functions, you cannot split the integral. But for the sum or difference of functions, you can do this. Does it make sense? Okay. Now you can find the antiderivative separately. So what is the antiderivative of 2 times x squared? What is the antiderivative of 2x squared? So 2x squared, sorry, 2x cubed divided by 3. So the two doesn't do anything. So that means I only need to find the antiderivative of x squared. The antiderivative of x squared is x cubed divided by 3, and then you still need to keep the 2. And then I need to plug in 1 and 3. Do the same thing for the second and the last integrals. So the second term would be 7x squared divided by 2, plugging in 1 and 3, plus the antiderivative of 5 is, what is the antiderivative of 5? 5x. I'm glad that no one says it's 0, so that's a good thing. The antiderivative of 5 is 5 times x, and then you need to put in 1 and 3. I'm not going to compute this, I will let you do the rest. So put in 3 for each term, and then put in 1 for each term, subtract. Question? All right. So still, we have the example with the integral of 2 minus x squared divided by square root of x from 1 to 4. What do I do? So what do you think I can do? Any ideas? Yes. Yep. So we can do this. Again, so this is a fraction. So the original question was the fraction of two functions. My point is you're not allowed to compute the integral of the top and the bottom separately. And so you have to do this. You have to split them into two parts. Then what? So what is 2 over root x? What does it look like? What is it in terms of x to the something? Okay, so before taking the antiderivative, 1 over root x is just x to the negative 1/2. And it's 2 times that. I'm going to split them up like this. What about the second term? X squared divided by root x. Okay, it's x squared minus 1/2. So like this. X to the 1/2 is 3/2. Is it okay so far? So I haven't done the antiderivative yet. This is all before taking the antiderivative. And so next step, I want to find the antiderivatives of 2x to the negative 1/2 and the antiderivative of x to the 3/2. What is the antiderivative of 2 times x to the negative 1/2? What is it? You use the same formula again. So you're going to get something like 2x to the negative 1/2 plus 1 divided by negative 1/2 plus 1, plugging in 1 and 4, minus the antiderivative of x to the 3/2. You get x to the 3/2 plus 1 divided by 3/2 plus 1, plugging in 1 and 4. Does it make sense? Questions? Okay. By the way, what's the reason that I can use the fundamental theorem of calculus? We're dividing by root x, so it's actually not continuous. It's not continuous everywhere, but what is the reason that we can use the fundamental theorem of calculus? Okay, I say that it's not continuous it's not continuous everywhere, but it's continuous from 1 to 4, and that's enough. If the function is continuous on the interval given by your lower limit and upper limit, then you can use the fundamental theorem of calculus. All right, and I'll let you compute this one. So you plug in 4 and 1, and then you get the final answer. Questions? Questions? Okay. All right, so to give you some motivations to study for the exam, I want to do some multiple choice questions from last year. So this is the second exam from the fall semester. So which of the following is the equation of the horizontal asymptote of the curve? So I hope you can see the function, but let me write this down. So how do I find a horizontal asymptote again? So horizontal asymptote looks like this, right? In your graph, it looks like this. It's the asymptote so that when x approaches negative infinity or positive infinity, it gets closer and closer to the horizontal line. That was the definition. And how do I find the horizontal asymptote? Any ideas? Yeah, basically that. So we need to compute the limit when x goes to infinity and the limit when x goes to negative infinity. So need to compute to find horizontal asymptote, need to compute two things. I need to compute this and this. But because negative x is not in the domain, I actually don't need this. Does it make sense? You have root x in your function, so x cannot be negative. So that means I only need to check the first one. So let's compute that. And Derek was correct. So you need to compute the limit like this. We only need the highest degree terms on top and bottom. So the highest degree term on top should be 3x. The highest degree term bottom is negative x squared. Does everyone see that? So once you multiply x and x and 1 minus x, you see that the highest degree term at the bottom is negative x squared, and the highest degree on top is 3x. Is it okay? And now divide the x, you get 3 over negative x. So what happens when I take x to infinity? Zero. So that means y equals 0 is a horizontal asymptote. Questions?